Hey there, this is Mr. Thomas, and I'm going to use a table of values from Moore's Law to get to a point where I can see what's going on here mathematically. First of all, here I've shown my steps in this first column. Step 0 is really my starting point. So in this case, I'm using 1972's value for the number of transistors on a chip by Intel as 3,500. And then each step after that actually corresponds to a 2-year doubling, right? Because Moore's Law says that the number of transistors on that chip should be able to double every 2 years. So in step 1, that's after 2 years, I have 3,500 times 2, which is 7,000 transistors. Then in step 2, I multiply that 7,000 by 2 to get 14,000 transistors, and then 28,000 transistors and 56,000 transistors in step 4. Each time to get the next step, I multiply the previous step by 2. Now, to expand this out, this is going to help me get to a form where I can see what's going on here. So my first two steps, step 0 and step 1, are going to be the same. I'm still going to write those equations the same way. But then in step 2, I've got 7,000 times 2. Instead of writing 7,000, I'm going to write that as 3,500 times 2. So I've got 3,500 times 2, that's my 7,000, times 2. So every time I'm going to take the calculation I used from the previous step and then multiply that by 2. So for step 3, I have that 3,500 times 2 times 2 that I had in my expression for step 2, and then I take that and multiply that by 2. And then for step 4, of course, I have 3,500 times 2 times 2 times 2, and I'm doubling that. So that gives me my expanded form for step 4. Now I'm ready to see what's going on here mathematically. When I make a new column for exponential form, I'm going to skip over step 0 for now because I'll work back there, trust me. So for step 1, I see that I only have 1 2 that I'm multiplying by the 3,500, so I have 3,500 times 2 to the 1. Then for step 2, I have 3,500 times, well, I've got 2 2's. Well, I can write that exponentially as 2 squared. In step 3, I have 3 2's being multiplied, so that's 2 cubed. And in step 4, I have 4 2's being multiplied, so that is 2 to the 4th. So my exponential form looks like 3,500 times 2 to the 1st for step 1, 2 to the 2nd for step 2, 2 to the 3rd for step 3, and 2 to the 4th for step 4. Well, now all of a sudden I'm starting to see a pattern here. I feel like if I've got 1, 2, 3, 4, maybe the first one should have been 0. And I can see that if instead of writing 3,500 for my expanded form, if I wrote 3,500 times 1, well, 1 is 2 to the 0. And now, looking at the exponential form, I can see that the exponent on my 2 goes from 0 to 1 to 2 to 3 to 4. So that means that my exponent on 2 always is going to be equal to the step number. So my formula for this is that my computing power, I'll use C for the function name, C of S, where S is my step number, equals my initial computing power, C of 0, times 2 to the S. So all I have to do is take my base of 2, raise it to the power of the number of steps I want, and that's my formula. C of S equals C of 0 times 2 to the S.